As Cameron mentioned, I'm a navigation engineer, so it's our job to essentially be an interplanetary Google Maps. We want to know where a spacecraft is, make sure it doesn't get lost in like a one-sentence nutshell. So of course, Artemis II, that was a really big deal, and it was really incredible to be able to work on this mission. And what is this? The moon. Okay, good. You're all still awake. So obviously the moon, other than the sun, is the brightest thing in our sky. It's very captivating. It's very beautiful. Hopefully people, if you haven't ever had a chance to look at the moon through a telescope, hopefully you can do that tonight. Maybe use your chicken wing elbows. That's what my dad called me when I was a basketball player. Use your chicken wing elbows to cut in line and go look at the moon. So the moon is beautiful. And of course, we only ever see one side of the moon. The moon is tidally locked, which means that the same face of the moon is always facing us here on the Earth. So everything that we see is the only thing that we will see unless we are lucky enough to be an astronaut and go off into space and see the far side of the moon or the dark side of the moon. Now, how much we see of that near side of the moon depends on where the moon is in its orbit about the Earth and how much of the moon is lit by the sun at any one time. But the thing does anyone think that there's anything special about this photo? Anyone? It shows off the depths of the craters? Yes. Anyone? It's the far side, yes. So this is actually a picture that the Artemis II crew took during their lunar flyby. And so obviously we've seen the far side of the moon before. We have had robotic explorers that have studied the moon for a long time. So this was not the first time that we had seen the dark side, the far side of the moon, but it was the first time that human eyes had seen the dark side of the moon in over 50 years. And so it's a really pretty image. I think it's a really pretty image. And now this is a video that, and I don't know. So again, I haven't given a talk this short in a really long time. So to summarize Artemis, instead of me talking about it for 20 minutes, we're going to watch a 3-minute video.
Taking their first steps outside for their historic test flight.
4 brave explorers ready to ride the most powerful rocket NASA has ever launched.
Reed, Victor, Christina, and Jeremy.
We are going for our families.
We are going for our teammates.
We are going for all humanity.
Engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon.
Houston integrity, great view.
This is a test flight, and so every single system aboard Orion is getting tested by humans for the first time. That is Earth in the center of your screen from the Orion spacecraft, looking back at all of us.
Houston is go for TLI.
With this burn to the moon, we do not leave Earth, we choose it.
The 4 of us have looked at this moon our entire lives, and the way we are responding to what we are seeing out the window, it's just like we're a bunch of little kids up here, we cannot get enough of this.
That is something we have never seen before.
It's hard to wrap your mind around. Like, I mean that sincerely. It really bends your mind.
As we prepare to go out of radio communication, to all of you down there on Earth and around Earth, we love you from the moon.
Just seeing Psyche, there's mountains to the north. You can see Copernicus, Rainier Gamma. It's just everything from the training, but in 3 dimension and absolutely unbelievable.
Kathy Moonjoy. Superlative thumbs up.
We just went sci-fi.
I think there is enough for all. The purpose of humanity is joy and lifting one another up, creating together.
This is a whole bunch of nothing, this thing we call the universe. You have this oasis, this beautiful place that we get to exist together.
Well, I'll tell you, I mean, after ignition, to me, the moment that I'm going to be most excited for is splashdown. There's no question about that. Good shoots coming down off the West Coast.
And there go the first series of parachutes.
And Houston, we're visual 2 drones out the window.
Main chute deploy.
We most importantly choose this moment to challenge this generation and in the next to make sure this record is not long-lived.
This is a relay race.
It takes an army to pull a mission together like this, right? Across all 10 of our centers, all of our commercial partners, the international partners that come together to make this possible.
The size and the scale and the scope of Artemis II is not something that any one center, any one agency, or any one country can do. And so Artemis II involved work from all of our NASA centers. It involved work from commercial partners. It involved support from international partners. So the service module, which is what the capsule was attached to during the 10 days that provided the power and the maneuverability and all the important stuff, that service module was built by the European Space Agency. So there was a lot of collaboration that was really important and was vital to the success of Artemis II. So it wasn't just us. We didn't do it alone. So one of the things that they talked about in the video is that Artemis II is a test flight. And so essentially what that means is that really the primary purpose of this mission was to ensure all of the systems that we need to safely send humans out into space and then, of course, bring them back home, that all of those systems work the way we expect them to. So your life support systems, your maneuverability systems, your communication systems, your navigation systems. Now, we've done deep space navigation for quite a while, so we know how to do that, but it's a little bit different with people on board. And so we want to make sure that all of those systems work the way we plan. We want to make sure that when they come back into land, that goes the way we plan. There's a big difference in supporting humans in low Earth orbit and supporting humans in deep space. So humans have been living and working aboard the International Space Station in low Earth orbit for decades now. So we're pretty comfortable. We understand how to support humans in low Earth orbit. We understand how to send them there. We understand how to support them there. We understand how to bring them home. But the moon is a different animal. You're coming from much farther away, so when you're re-entering at much faster speeds. It's much hotter. So it's not the same thing, and you can't just, do a linear extrapolation to say, okay, if I'm coming back from the ISS here, it's going to be, this much harder coming back from the moon. It doesn't scale that same way. So we want to make sure that we understand how all of that works. Because in sort of the language that, NASA has about Artemis, obviously we've been to the moon before back in the Apollo era over 50 years ago. But this time we want to return to the moon and we want to stay. If you ask 10 different space enthusiasts, I'm sure I could pull, 6 different people in this audience about, what should be the future for human exploration? Should we go to the moon? Should we go to Mars? Should we go to the moon and then Mars? If I pulled 6 different people, I would get 6 different answers. And so lots of people have lots of opinions. There are lots of merits to lots of different ways to send humans out into space, where they should go, what they should be doing. And so the approach that NASA is taking right now is doing a Moon to Mars campaign. And so the idea is that we send humans back to the moon first. That's a little bit closer. That's a little bit easier than sending humans all the way out to Mars. We figure out how to do that in a sustained way. And then once we get that all buttoned up, then we can look towards sending humans to Mars. And so Artemis II is the next step in that journey to returning humans more permanently to the moon and then ultimately to Mars. Christina Cook, in that video that I showed, talks about this being the first leg of a relay race. So there's a big legacy that Artemis II will hopefully be leaving behind, although it's weird to talk about a legacy for something that's 17 days old. But here we are. So, at a high level, Artemis II is really a test flight. It is really a technology demonstration. But in addition to that, we are doing science. Now, I'm not a scientist. I'm an engineer. But some of the science, thanks, engineers, wherever you are. But in terms of the science, there is still some cool science that Artemis II was doing. So, yes, I don't have a laser pointer. In the upper left, what you're looking at, because NASA has to make everything more complicated, this is an actigraphy device. It's basically a smartwatch. And so the different sensors on here are monitoring their sleep habits, their motion, how much light the astronauts receive. So I was actually, Cameron mentioned I was an analog astronaut, so I didn't go outside for 45 days. So the only medication that I was allowed to take was vitamin D to make sure that didn't get all out of whack. So monitoring the crew's health was one of the single biggest science studies for Artemis II, because we want to understand how human health, how human behavior changes in these really remote, really isolated environments. One of the things that we have learned from past human space exploration is that there is actually a psychological difference when you travel into deep space. When you're aboard the ISS, if something goes wrong, I'll put pretty easy in air quotes. By space travel standards, it is pretty easy to get back home, right? The Earth is right there. You can pop in a capsule. You have an emergency switch to say, you know what, this has gone belly up. Like, I need to get out ASAP. When you're all the way out at the moon, when you're all the way out at Mars, you don't have that same emergency switch, right? Anyone seen Apollo 13? Okay, great. I've asked this question when I've done outreach in schools, and not a single hand goes up. Like, I didn't think I was old. I'm not old. So like, we all saw Apollo 13, right? We know that if something goes wrong in deep space, it's not easy to get astronauts home. And so for an astronaut, when you're in deep space, there's a psychological difference that has been studied and documented that you experience. You know it's different being in deep space versus being aboard the International Space Station. And so that's one of the things that we want to study and better understand when we're sending humans to deep space. So that was a really long explanation for the first picture. The second one, hopefully I can be a little bit more succinct. One of the other big science goals for Artemis II was to do lunar geology observations. Now, I mentioned earlier that this was the first time human eyes had seen the far side of the moon in over 50 years, because we have sent robotic spacecraft to the moon, obviously to the surface, as we just heard about in that great presentation. We have the Lunar Reconnaissance Orbiter, LRO, that has been orbiting the moon. So we've seen the far side of the moon, but human eyes haven't in a really long time. And there is value in humans looking at the far side of the moon, and there was value for Artemis II to be studying the far side of the moon, because they were looking at the far side in rapidly changing lighting conditions that would have taken a robotic explorer years to replicate. And so when you look at the far side in different lighting conditions, when I showed that picture at the very beginning, you can illuminate different features in different ways. And so there's a lot of value still for humans to perform these studies, right? Because we have pretty good brains when we use them correctly. And so, we can, apply context to observations. We can apply a lot more information to a single picture than a robotic spacecraft can. So we still wanted all of our astronauts to be performing these lunar observations. And so to do that, the astronauts aren't necessarily all expert geologists who have PhDs. And so they did a lot of studying ahead of time, and they would go on different field trips. And this one happens to be in Iceland. That's Christina Cook there in the orange jacket, with then a professional geologist, and unfortunately I can't remember her name, but getting ready to do the lunar geology. This is Victor Glover actually doing lunar geology observations during the flyby. I think it's a really cool image. He's just like looking out into the void, into the cosmos, just absorbing what it looks like. Because again, the moon is something that we all have a very visceral, real attachment to. Sometimes I think when we talk about different space missions and telescopes in particular, we see these beautiful images, we see all these really cool things, but it can sometimes be hard to wrap your brain around what's really going on, just the size and the scope and the scale, and it's not something that we can always immediately relate to. But the moon is something that we all understand. The moon is something that we have all seen. And so for them to see it in this different way and then be able to share that back with us, I think was really moving. This is also super cool. This is a real image, not AI, real image right here. So does anyone have a guess what this is? An eclipse. Oh my gosh. I mean, I'm feeding you guys softball questions, but thank you anyway. So this is really cool, because this is the first time, as far as I'm aware, that humans have seen something like this. So what you're looking at here is the moon eclipsing the sun as seen by the Artemis II crew after they flew by the moon and were on their way home. So if you look kind of at the left side, if you look carefully, you might even be able to see some of the craters of the moon that are still lit by the sun. And then around the moon, you can see this glow. And so scientists, they're still studying this image, still figuring out exactly what it is. It's likely either the sun's corona, which is the upper atmosphere of the sun. The sun has an atmosphere, in case you didn't know. So it could be the corona of the sun, Or it could be something called I'm going to mispronounce this in front of astronomers. That's going to be embarrassing. It's the zodiacal background. Hopefully that was close enough. So essentially, like there's dust in space and it can be illuminated and then sort of cause this glow. So they're not sure how much is the corona, how much is just kind of the background that we might see otherwise. But it's really cool regardless. And in the video, again, that I showed Victor Glover when he was describing this in real time, he said, we just went sci-fi. I mean, which I think is the perfect description for what this is. Because like this doesn't look real. I mean, it looks like, I don't know, it looks like something you'd see in a television show. And the really cool thing about this too is that we launched Artemis II on April 1st. And the only time when the sun, the moon, and the Artemis II spacecraft were going to align correctly for the astronauts to see this was if we launched on April 1st or April 2nd. So we got really lucky that we launched when we did so that we could see this. So that is also really cool. Really quickly, because I have no idea how long I've been talking already, one of the other cool things about Artemis II was that for the very first time, we had a science officer in mission control on the floor, which just goes to show how important science is to the future of humans exploring these other places. And so we'll have more. I think Kelsey Young, she was the main science officer, and she's this one right here in the middle, Dr. Kelsey Young. Yay! So really quickly, for anyone who has been living under a rock, this is the Artemis II crew. So starting from the left, moving to the right, you have our commander, Reed Weissman, then the pilot, Victor Glover, and then mission specialist, Christina Cook. These three are all NASA astronauts. And then our last member of the crew was another mission specialist, Jeremy Hansen, who was a Canadian astronaut. Yay! So the really cool thing about Artemis II, right, is that this crew looks a little bit different than the crews of the Apollo era. And so they have hair. Yes, thank you. So that's the only difference. So by design, Artemis II was intended to be this international effort, right? We aren't just returning Americans to the moon, we're returning humanity to the moon. And the cool thing about this particular group of people is that they all have very unique stories. They have all traveled different roads. They have all gone through very different challenges. Reed Weissman's wife died of cancer. Jeremy Hansen was selected as an astronaut in 2009. I'll say that again, 2009, and the first time he went into space was on this mission. So he had to wait 17 years to go into space, and then he gets to be part of Artemis II. So patience pays off for people in the audience. So they're all very interesting people. I don't have enough time to talk about them, but they're fantastic if you haven't done a deep dive into their bios yet. Because I'm a navigation engineer and orbits aren't always boring. I'm kidding. This is an animated graphic of the Artemis II trajectory. And I'm really glad that you saw another trajectory for how to get to the moon, because this is going to look really different. So our last presenter was talking about how it takes a couple months to get to the moon because you're doing kind of a spiral out from the Earth and then a spiral back down to the moon. And obviously here we're not doing any of that. This whole mission took 10 days. So initially we launched from the Earth, and then you had that first orbit about the Earth, and that whole thing took 24 hours. And the intent behind that was to make sure everything worked the way we expected it to, right? Before you send humans all the way out to the moon, you better be sure that they're going to make and survive the trip. So I'll move on to the next just because you can see the trajectory a little bit better. So you can see this kind of figure 8 trajectory here. So you come out, you do this loop about the Earth, and then you perform that translunar injection burn that I was talking about. And then you're on this path out to the moon, then you orbit, you fly by the moon, and then you come back on this blue trajectory and then land off the coast of San Diego. This is what we call a free return trajectory. which means that we did not have to do any sort of maneuver once we were on our trajectory to the moon to ensure that the astronauts would come home. We all saw Apollo 13, or at least most of us have seen Apollo 13. So we wanted to make sure that we were not reliant on us performing a maneuver to ensure that they got home. Now, that doesn't mean that we didn't perform maneuvers, because we did. We wanted to make sure we flew by the moon in a very specific way. We wanted to make sure we landed exactly where we were supposed to and not in the middle of the Pacific Ocean. So we still performed maneuvers to fine-tune our trajectory, but we didn't have to do any massive maneuvers to ensure that the astronauts came home. So one of the funny things about being a navigator is that I never get to go to spacecraft launches because the navigation, yes, oh, it is very sad. Thank you. Thank you for acknowledging my pain. Because our job begins essentially, depending on the mission and depending on the trajectory, it begins essentially 45 minutes to an hour after the spacecraft has launched. So we work with the launch vehicle provider, the rocket people. And so the rocket people launch the spacecraft, and then the spacecraft separates from the rocket. And then the spacecraft is on its trajectory going somewhere, whether that's the moon, whether that's Mars, whether that's an asteroid, wherever it may be. And so once the spacecraft is on its own and is on its way to its destination, that is when our job begins. So since my job starts really shortly after launch, I never get to go see anything. So I didn't get to see this. I didn't get to see the Falcon Heavy Launch Clipper back in October of 2024. But it is kind of fun because we're all in the MSA, the mission support area at JPL together, eagerly awaiting the information to come back so we can start doing our job. So you still have that sense of camaraderie. You just don't necessarily get the same wow factor. But this is a really cool image, just kind of walking through a couple of my favorite pictures from the mission. That was launch. Obviously, splashdown, incredibly important. Hopefully, I've made that clear, and hopefully I didn't have to make that clear to you guys that splashdown is really important. So this is really cool, right? I mean, like, there are 4 people in that tiny little capsule, and they've been in that tiny little capsule for 10 days. And you would think that after being in that tiny little capsule for 10 days, they'd be ready to get the hell out and go home, and they wouldn't need to hang out with their crew anymore. But look how happy they are. These are 2 of my favorite images of the entire mission because there is just such pure joy radiating from these 4 people. And so these are people who are at the pinnacle of their careers, right? They have worked really, really hard. They have worked really, really long hours, long years. They are dedicated. They are intense. They are intentional. They are focused. And they can still understand and channel this joy and this gratitude and be their 5-year-old selves that said, you know what, Mom, you know what, Dad, I'm going to be an astronaut one day. And they made it, and they did it. And I don't know, I get goosebumps thinking about it because I was that 5-year-old, and maybe my day will come. Who knows? But yes, thank you. So I love these images. I love the joy. And one of the things that was really interesting that I didn't fully appreciate while I was directly supporting Artemis during those 10 days was how much the world needed Artemis II. And so I went to, I'm a member of the Junior League of Pasadena, and we had our 100-year celebration the day after this landed. And so I was talking to some friends at the event, and every single one made a point to say how much fun it had been to watch this and how much joy they had gotten watching something positive in the news. I'm not going to get into politics, but right, there's a lot of stuff going on in the world and a lot of stuff that's not great to see in the news right now. And that's been true for a while. And so this was a bright spot for people. This was something that was fun, that was uplifting. People who were not space enthusiasts were still logging onto websites to see what wake-up song the astronauts were picking in the morning, right? I mean, like there was all this really cool stuff. And again, because it wasn't just Americans, it was a unifying effort for humanity. And it just was an incredibly cool mission. And I think, I was working the night shift, and I'll talk about that in just a second. But I think, I didn't fully process that as it was happening. And of course, I was not the only one doing this. We were part of what we actually call a shadow navigation team. So each NASA center typically has a specialty, and the specialty for JPL is robotic space exploration, as people probably know. And at Johnson, they are the manned spaceflight center, right? The crewed spaceflight center. They work with all the people, all the astronauts. And so because Artemis II had people on board, it was primarily a Johnson mission. But because JPL has an expertise in navigation, we were asked to support this effort just as kind of an independent double check to make sure everything was going exactly as it should. And so there were 7 of us, if I can count correctly, who are part of this small team to do this independent navigation for Artemis. So just really quickly, because I want to make sure everyone gets credit where credit is due. We have Gerard Krasinga, Burton Yale, who's here, but I won't make him stand up, Shamita Nandi, Mark Ryan, Tomas Martin Moore, and then our remote member, Drew Jones, who is in Texas. So at the bottom, you can see we are working very seriously, or at least pretending that we are. And so that was our mission support area that we were in for the 10 days of the mission. And we ate lots of popcorn, lots of peanuts, among other nuts. Thank you. Yes, it's a tradition, not a superstition, just to make that clear. It was really cool to work with these people. And we have a couple people who are actually about to retire. So Shamita's about to retire. Mark Ryan had retired and came back. So there's a lot of expertise on this team, and it was really cool to all work together and be a part of this group. Thank you. So I'm almost finished. Just a couple more pictures. So this one, again, is one that the Artemis II crew took. And so does it remind anybody of another famous NASA image? Earthrise, thank you, yes. So Earthrise is a super famous image that Apollo 8 took back in the late 60s because Apollo 8, of course, was the first mission that we sent with humans to the moon. They did something, their trajectory wasn't exactly the same. They actually orbited the moon, whereas we did a flyby with Artemis II. But Apollo 8 was the first time humans went to and orbited the moon, and then they came back. And so they took this really, not this one, but another very famous image called Earthrise. And now Artemis II took this image. And so Earth was rising in the other image from Apollo 8. Earth is setting in this image. So I don't know if it's officially called Earth Set or not, but it's a really cool bookend, I think, kind of between Apollo 8 and Artemis II. And it's a beautiful image just of the moon. It's very crisp. It's very clear. And I point that out because this image is not. I worked the night shift for Artemis II. So for 10 days, I was nocturnal. I was working, like 11 to 9 or midnight to 10 or something like that. So the night shift is kind of rough. Humans are not meant, most humans are, certainly me at least, not meant to work at night over a sustained period of time. But the really cool thing about working at night, especially for Artemis, is that I got to see the moon every night when I went into work. And so the picture on the right, we were waiting for some data to come back that we could analyze. And so a coworker who was on shift with me said, "Hey, let's go look at the moon." And so he went to the moon, and then he was like, "Point to the moon and I'll take your picture." And so that's me pointing at the moon the day that we launched. And it was really cool because it's not as common for the missions that I have supported in the past for me to see the destination of my spacecraft at the very beginning, right? If you're sending a mission to Mars, Mars probably isn't visible in the sky the day that you launch. When we were sending, when we were launching Psyche, you certainly could not see the Psyche asteroid in the sky. So it was very unique and very special to be able to see the moon and know, okay, like that's where they're going. They're on their way there right now. And hopefully I'm not going to get emotional. When I ran through this earlier today, I almost cried. So the one on the right is from launch day. And then this is a picture that I took from my apartment the day of the lunar flyby. And so this is just with my phone. So obviously it's not a great image. But again, it was this crazy reminder that even though my technical job was mostly the same, right? I'm getting data back from the Deep Space Network. We're my DSN people. Thank you. So the Deep Space Network was also critical to Artemis. That's the network of antennas that we use to communicate with Artemis and get all of the data back from the mission. So even though my job technically was the same, right, I'm getting data back from the spacecraft, I'm using that data and the models of how I expect it to behave to understand if it's behaving the way I expect, and then using that information to predict where it's going to go to ensure that it's going to the right place. So that all was the same. Now the models were a little bit different. It was kind of fun. We got to model the astronauts' behavior of when they were awake versus when they were asleep versus when they were exercising. And there were a couple of times when they were, it didn't seem, the data we got back from when they were exercising didn't seem to match, so we weren't sure if they were working out hard enough or not. So at a technical level, right, my job was basically the same. I'm getting data back, I'm processing it like normal, but the consequences are vastly different, right? Because there are 4 people on board. There are 4 people who are counting on not just me, but our whole team to do our job to make sure that they get to come home. And so I get chills kind of thinking about that, knowing that I was a really small part of being able to contribute to something that was this big and this meaningful for this many people. So hopefully that wasn't too long, and now I can take questions.